About exponents that can be written as fractions. Okay, we are going to see these fractional exponents written as some value p over some value q. P is found where you would normally find an exponent, right? Some superscript number over here. Okay? Q, however, is going to be a root. So that could be a square root, a cubed root, a fourth root, a fifth root, right? So that Q number could change just like your exponent could be 2, 3, 4, 5, 6, 7, anything like that. Okay? So it says we're going to use this definition to simplify each of the following. So remember, you can go from it being written like this and turn it into this, or it could be written this way and you turn it into this. Whichever way is more helpful, more beneficial. So, I don't know about you, but off the top of my head, if I don't have a calculator, I'm not going to probably be able to compute what 16 to the 3 halves is if I don't rewrite it. Okay? So remember, the top number is your exponent. So this is like your normal exponent. And this bottom number is your root. So, I would rewrite this as a square root. When it's a square root, you don't have to put the 2. Just like when it's an exponent of 1, you don't have to put the 1. It's understood, okay? So we'll have the square root of 16, okay? And our exponent is 3. All right? So, order of operations, we start inside first. So inside of this parenthesis, I have the square root of 16. And what is the square root of 16? 4. So this would simplify down to 4 to the third power. Okay? And 4 to the third power means 4 times 4 times 4, right? Well, 4 times 4 is, and 16 times 4 is 64. Nice. So in this case, it was actually more beneficial to us to write it expanded than it was to have it condensed, right? Okay? Same thing for number 2. All right, same idea. So what's my root on example number 2? 3. So I'm going to have a cubed root of 27, all raised to what exponent? Negative 2. Okay, so just like before, I'm going to start on the inside. So inside means I'm taking the cubed root of 27. That means what multiplies times itself 3 times to get me 27, right? So 3. So this would be equivalent to 3 to the negative 2, right? But we don't like a negative exponent, so how do I fix it? Yeah, so I could rewrite this as 1 over 3 squared, right? So it'd be 1 over 9. And then we don't have to deal with decimals, right? Okay? All right, on number 3, how am I going to rewrite number 3? What does this exponent mean? Uh-huh. Okay. Okay. So just a normal root of 9 over 25. Okay, so I'm taking the square root of everything underneath there, right? Top and bottom. So what's the square root of 9 on the top? And the square root of 25 on the bottom? Nice. Okay. So now we can see why it would be helpful to take it from here back to here, right? But sometimes we don't have just numbers under there, right? We've got variables. And I can't actually take the square root of a letter, right? So that's when it's more beneficial to write them as the fractional exponent. So that's what we're going to see in the next section. So we're going to simplify maybe whole numbers if we can, but we're probably going to have those rational exponents for our letters, okay? So we've got, for number 4, the 6th root of 27, a to the negative 1, b squared, all raised to the 4th power. Okay, so we've got a sixth root, right? But let's think about this. 27, not an ideal value there, right? I want to simplify it if I can, okay? So earlier, up here, we had 27, and we took the third root of it, right? So 3 to the third power is the same as 27, okay? So what I'm going to do is I'm going to rewrite 27 as just 3 to the third power, okay? And then I'm going to keep my a to the negative 1 and my b squared. But instead of writing a sixth root over it, I'm going to change that into a fraction. Okay? Ignore the 4 for now. How would I rewrite the sixth root as a fractional exponent? How did we have a square root written as an exponent? Yeah, so it'll just be 1 over 6. Okay? So I haven't really changed anything. All I did was instead of putting a sixth root over it, I just rewrote it as 1 over 6 instead. Okay? But it is still all raised to that fourth power, right? Okay. All right. So let's see here. Let's simplify inside first. So inside this parenthesis, not a lot I can do here, okay? But this whole parenthesis is raised to the 1/6, right? And I do inside first, so I'm going to have to do the 1/6 before I get to the 4, because we start inside, right? Okay? Now remember, we just went over this with laws of exponents. When we have these exponents raised to another exponent, what do we do with them? Multiply. Okay, so for 3, I'm going to have 3 times 1/6. That'd be 3 over 6, right? Right? 3 times 1/6 is just 3 over 6, right? And 3 over 6 is equivalent to 1/2. Okay, so really we've got 3 to the 1/2, okay? I'm also going to multiply negative 1 times 1/6. What would that be? Right, so I'll have a to the negative 1/6. And then I also am going to multiply 2 times 1/6. 2 over 6. And what's 2 over 6 equivalent to? 1/3. So I'd have b to the 1/3. All right, and this is all still raised to that exponent of 4, right? Okay, now I can multiply by the exponent of 4, right? Okay. So I'm going to have 1/2 times 4. It's 2, right? 1/2 times 4 would be 4 over 2, right? Which is just 2. Okay, so I'm going to have 3 squared, all right? And then 1/6 times 4. Negative 4 over 6, which is, okay? So we got a to the negative 2/3, and then 1/3 times 4. 4/3. So b to the 4/3. Okay. Now, like we said, when it's a number, you can actually square it or take its square root, things like that, right? So I can actually square the 3. The 3 squared will become 9. Okay? Now, as far as the a, I cannot actually raise it to the negative 2 power and take its cubed root, right? Okay, the only thing I might want to do is I don't like a negative exponent, so how could I make it a positive exponent? Just move it to the bottom. So it'd just be a to the 2/3 in the bottom, okay? And then I cannot actually take the third root of b and raise it to the 4th power, so it stays as it is, and it's not negative, so no need to move it. So it'll stay b to the 4/3 in the top. All right, so we're combining our laws of exponents with the rational exponents, okay? All right, so let's do another one. Okay, number 5, we've got the square root of x times the cube root of x times the 6th root of x. So let's rewrite that. How could I rewrite a square root as an exponent? So x to the 1/2, times, how do I write a cubed root as an exponent? So x to the 1/3 times, how do we write a sixth root as an exponent? Right, times x to the 1/6. Oops. Okay. All right. So recalling our rules, we are multiplying. What do we do with exponents when we multiply? Add them. Right. Okay. So I'm going to have x to the 1/2 plus 1/3 plus 1/6, right? I want to add these three fractions. But if I add fractions, what do I have to have? Common denominator. So between 2, 3, and 6, what should be our denominator? 6. What would you multiply 1/2 by to turn its denominator into 6? So we'd multiply the top by 3 as well, right? So it would become 3/6, right? Plus, what would I multiply the 1/3 by to fix it? 2. So it would become 2/6, right? Plus, we don't have to do anything to the 1/6. You guys said we're just adding up all these exponents, right? So what's 3/6 plus 2/6 plus 1/6? 6/6, right? So this becomes 6/6, which, yes, I heard you say is 1. And anything to the first power is itself, right? So this is just x. All right. Okay. Number 6. What are we going to need to do on number 6? Distribute. Very good. Okay, so I'm multiplying. And again, when I multiply, what do I do with my exponents? Add them. Okay, so the understood number in front of this x is a 1, right? So I'm going to actually multiply the 3 times 1, which would give me 3. And then you said for the exponents, I'm going to add them. So that would be negative 1/3 plus 1/3. Yeah, so it'd just be 0, right? So x to the 0. Okay? Now, I got to multiply that also by this negative 4x to the 4/3. So I'm going to have 3 times negative 4, which would give us negative 12. All right, and then we are going to add those exponents. Yes, and we will get 3/3. All right, well, we know anything to the 0 power is actually just what? 1. So this is really like having 3 times 1, which is just 3. Minus 12 times x to the first. And I don't actually have to put x to the first, right? So it would just be 3 minus 12x. All right. Okay, we got one more. This one actually has all numbers, right? No variables in this one. Okay, so remember we start inside. So inside, anything I could maybe do to fix this? Or what do you guys think we should do first? What do y'all want to do? Don't let me speak for you. Like move them to the bottom? Okay, we can do that. So you're saying inside the parenthesis, make this a 1/2 and a 1/4? Yeah, so that these exponents are now positive ones down here in the bottom? Yes, you can most certainly do that. Okay. So we've got 1/2 plus 1/4 raised to the negative 1. Again, I'm supposed to simplify inside the parentheses first, right? Okay, parentheses comes before exponents, so I can't deal with that negative 1 yet. I do need to simplify. I can't add them as they are because I need a what? Right. So what would I change 1/2 into? 2/4. So inside here, I would actually have 2/4 plus 1/4, right? And what is 2/4 plus 1/4? 3/4. So I've got 3/4 to the negative 1. And now that I've taken care of the inside, right? Now that I've taken care of inside, now we can move on to exponents, right? After parentheses is exponents. So everything in there is being raised to the -1. So I have 3 raised to the -1 over 4 raised to the -1, right? But we don't like a negative exponent, so what am I going to do? Flip them. So I'll have a 4 in the top now and a 3 in the bottom, right? Okay. All right.